Looking at solving systems. And the first thing you have to know is, what is a system? Okay, before you understand a solution, you have to know what a system is. So a system is two or more equations or graphs. So we'll be looking at solutions of systems by looking at two graphs or two equations. What we have down here, our first example, is a graph of two different lines. This line is y equals negative x minus 1. The other one is equation is 3x minus 5. You can double check their slope and y-intercept to make sure it's right. Correct equations. All right, so the first thing we have to remember is we're looking for where the graph intersects and meets. That is a solution. So when you are finding a solution, you're looking for the point of intersection. Our graph meets where?
1, negative 2.
Very good. Right there where the two lines cross, that coordinate right there, we're listed on the side, that is 1, negative 2. Now notice, this is the only point that's on both lines. It's the only shared x and y value on both lines. Again, the only one on both. That means that shared point is the same x and the same y. And we can go a step further and double check that's the right solution, because a solution is if I put this 1 in, this input of 1, this x value of 1, if I put that into either equation, I should get the same shared output of negative 2. So plug in 1 to the first equation, 3 times 1, and then minus 5. That's going to be negative 2. Over here, negative 1 minus 1, again, will be negative 2. All right, so remember, we will always write a solution as a XY coordinate or pair. Now, we are looking at our first method of solving a system, and that method is graphing. So what is the easiest form that we've learned over the last couple weeks? What's the easiest form to graph?
Slope intercept.
Very good, slope intercept. So what you want to do is make sure you convert, if it's not already done for you, convert your equations to slope intercepts to be able to graph them. All right, let's go ahead and do our first example down below where we have to do our own graphing. Let me zoom in on this one. All right, both equations are ready to go. That means they're in slope intercept form. They're ready to be graphed. So the first one, I'm going to make that one green. So why we convert to slope intercept? Because we could plot the b, the y-intercept, which is what in this one? Negative 3. So I'm going to go with my y-intercept of negative 3. Put a point. And then how am I going to move to my next point?
2 over 1.
Good. My slope is positive 2. If it helps, you put it over number 1 there. That's going to tell us to go up 2 into the right 1. Add a couple more points to be more precise. Up 2 to the right 1. If I want to go the other direction, just do the opposite for both. Go down 2 and left 1. All right, we have plenty of points there. Let's go ahead and draw a straight line. All right, there's our first line, our first graph. Is that my solution right there? No, we don't see the other line yet. We can't say a solution until we see two lines crossing. All right, now let's make this a different color. I'm going to go magenta. All right, so the second equation is y equals x minus 1. So again, plot the b first. So I'm going to go to my negative 1 on the y-axis. Put a point. And my slope is 1 over 1. So up 1 to the right 1. Is that my solution right there?
No.
What key feature would that be, though, of this line? Awesome, the x-intercept. If I go up 1 over 1, what happens? They connect. We land on a shared point. All right, so I'm going to go ahead and draw the line. All right, there's the second line on the graph. And now we see they have a shared coordinate, which will be our solution. They cross at that value there. What's that coordinate?
1.
X first, 2, and then the Y, 1. 2, 1 is the solution. All right, again, this is just graphing practice from weeks prior. Go ahead and move over to the next one here. And I want you to try that one on your own. This is our Padawan practice. All right, these are nicer equations than the ones that we're going to see in a minute. Again, because the Y's are by themselves. These are graph ready. These are ready to be graphed. All right, I'm going to make the top one green again. Okay, if you don't know how to graph, please follow along. This is the last time you ever see this in class. Positive 2 is my y-intercept. Begin by plotting positive 2 on the y-axis. Right there. After that, we're going to use a slope. This slope is negative 1 over 2. Let me remind you, that means to go down 1 and to the right 2. Down 1, right 2 will be right there on 2, 2. I'm sorry, 2, 1. 2, 1. 2, 1. Okay. Down 1, right 2 lands me on my x-intercept. Now, if I want to do the opposite, add more points to the left, I could do the opposite for both. Instead of instead of down, I go up. Instead of right, I go left. Up 1, left 2 is exactly the same thing. All right, I got plenty of points to make my line. See if I can do that on the fly. All right, looks pretty good. Almost. I see a little bit mistake in there. Move it up just slightly. There it is. All right, the next equation again is in slope-intercept, where we have the y-intercept, negative 3. And then the slope is also negative 3. So that means go down 3, and don't forget to run to the right 1. Down 3, right 1. Or just the opposite of both, up 3 and left 1. All right, there's our enough points to make a line. Let's go ahead and do that. All right, there's our second line. And now we see where they cross is the solution. This point right there is the solution. So let's list that down here. The x value is negative 2. The y value that's paired there is 3. All right, let's move down to the bottom examples. Whoops, that's what I want to do that. All right, here we go. All right, now this one right here is not in slope-intercept. The best way, what always works, is converting to slope-intercept. Get the y by itself. But we did learn another way, because these are, what form do we see up here? Standard form. We did learn another way to graph standard form by finding its what? Very good, the x and y intercepts. Okay, so we could do that, but one of these would be very difficult to do that with. That's this one here. Yeah, because 8 won't be divisible by 3 very well. Let's practice the intercept way on the first equation, and let's convert the second equation to slope-intercept. All right, so over here, we're going to find the x and y intercepts. So again, this is the x and y intercept method. We'll find the x first. What's always true about the x-intercept? Yeah, 0 is always for the y value. And just the opposite of that, our y-intercept will always have a 0 for x. So we're plugging in zeros to find the other. So let's do the first one here. Plug in 0 for y, looking at the equation above. Now we solve that one-step equation when 0 eliminates that. What's x have to be? 4. So 4 goes there. Plug in 0 for y. I'm sorry, for x. And we solve for that one. What do we get? 3. We have 2 points. Let's plot those 2 points. 0, 3. And 4, 0. Okay. Now we're going to graph the line through those points. All right, there's our first graph. Again, we just used the intercept method, but you can also solve for y. If you solve for y, you would get negative 4/3 of x plus 3. The plus 3 verifies our 0, 3 y-intercept, and the slope we would have got would have been negative 3/4. down 3 to the right 4. Same graph. All right, now let's go ahead and solve the other one for y. So the first thing we're going to do here is subtract 3x from both sides. That will leave us with 4y by itself equal to... Very good. Last step there. Divide everything by 4 to get the y equals equation. Y equals plus 2. Now, if you don't notice it now, you might notice it when you graph it. Let me zoom back out. A lot of people are saying parallel lines here. Okay, let's double check though. Let's graph it and see. So plot my y-intercept of positive 2. Go down 3 over 4. And then draw the line. And there's the second line. And we can see they're parallel. But how could we justify that these are parallel lines? Yeah. Same slope, good. They're both a slope of negative 3/4, but a different y-intercept. One's crossing at 3, one's crossing at 2, but they both have the same slope, down 3 over 4 for both of them. So we can verify that, and now we can see that there's how many points of intersection? None. So parallel lines like we see above have no solution because they never cross. Again, we saw they're parallel. We verified an equation because they have the same slope but different y-intercepts. All right, on the next example, we're going to see something weird happen. Okay. Now, a lot of you are freaking out because you worked ahead. But our first equation is nice. This is already in slope-intercept form, ready to graph. So I'm going to go ahead and do that. Graph it. I'm going to say that's green one again. Again, start with the y-intercept positive 5. Positive 5. And I'm going to go up 1 and to the right 5. Up 1 to the right 5. I'll add another point just to be safe. So do the opposite of that would be down 1 and left 5. Right about there. And again, that's already ready to be graphed. So I'm going to put my line. All right. All right, there's the first line there. And now we remember slope-intercept is the best way to graph. And we go to graph the next one. And it's not in any form at all. So we have to get the y by itself by first dividing by 5 on everything. So that's going to be, put this right here. Y is equal to, we have a 1/5 of x plus 5. Now, if you didn't recognize that, that's the same equation we have above. If you weren't able to recognize it and you go graph it, you would land on the exact same points. Go to 0, 5, and then up 1 over 5, or down 1 and left 5. All the same points, and I'm going to graph the line on top of it. And we're going to see that these are actually the exact same what? Line. The exact same line. And how do we know that?
Because they got the same slope, same y-intercept.
Yeah. Remember our last one did have the same slope. Like this one has the same slope, but this one has the same y-intercept. Okay, so when we see that, we're actually looking at a thing called coinciding lines. Coinciding lines. They coexist in the same space. Okay? And we know that's the same line. Just a fancy way of saying same line. The same line because we see the same exact slope and y-intercept. Yeah, we see the exact same equation. So how many points of intersection are there? Every single possible one. So an infinite number of intersections. So when we see these, the same slope and the same y-intercepts, and we graph them and we see the same line, we're going to think of these as infinite solutions. Infinite solutions. we've now seen all three possibilities where we had parallel lines down below that had no solution. Let me zoom in. We had no solution. Whoa. We had the same slope and different y-intercept there. Over here, we saw the exact same line gave us infinite solutions. And up above our first two examples, how many points of intersection are there for each of those? Just one. One. They only cross once. So our lines will cross once for one solution, or never cross at all for no solution, or cross every single point for infinite solutions. All right, so now we're looking at a graph of a system where we don't see the equations. So that's our actual job. We have to write the system of equations and then also state the solution. So let's take care of the easy part first. What can we see right away on the graph?
The solution.
Yeah, very good, the solution. The solution is where it crosses. And where does it cross? 3, -2. So we already have the solution figured out. 3, -2. Now the hard part here is going to be able to write the equations up here. So write the system of equations. Okay, so what do you think the best strategy will be? Find the y-intercept and slope. Okay, we're given the y-intercept and we can see the slope. So we're going to build these slope-intercept equations. All right, let's kind of keep organized here. Let's label this line on top. I'm going to call this line A. Okay, line A. For line A, again, we're going to use slope-intercept. We know it's going to be y equals. We do see the y-intercept is
1.
+1. And what's the slope here?
-x.
-1/1 or just -x. So our equation will be -x or -1x plus 1 for the y-intercepts. Not too bad. On the next one, we'll call this line B. For line B, again, it'll be y equals because we have the intercept given to us and we have the slope we can see. So the y-intercept is -3. And from there, we have to go up 1 and over 3. So positive 1/3 slope. So 1/3 of x, it crosses at -3. So that's it. There's the system of equations and its solution. All right, now, think of some good strategies to make your own system that has a solution of -3, 5.
So it could be anything that
So any two lines that cross that point. So again, you are going to graph it and then write your system of equations. All right, looking at our last example now. Our last one here. Did anybody find the solution without having to graph? Or without having to do any work at all? How'd you find it? The same shared point. Remember, the very first thing we learned about systems, they have to have the same pair, x, y, in both. Look at the table here. 4, -3, 4, -3. Those are the solutions. They have to be. And if we were to graph it, we're going to see them cross there as well. Now, if you weren't able to see those are the same points, remember, we share an x, y. That's a solution. The solution, and if I was to graph it, and I'm going to in a second, it will cross at 4, -3. So let's go ahead and verify it. All right, the first graph here of f of x is -1/2 x minus 1. So if you didn't see the solution, you can graph it to see it the other way, another representation. So go to 0, -1, and my slope is down 1 over 2, down 1 over 2, and draw the line. Our next graph starts at -4 and goes up 1 over 4. It actually lands on that point that we noticed that's in the table. 4, -3. Let's go ahead and graph the line though to verify it does cross there at 4, -3. And there's our solution. Whether you see it in the table, a shared point in the table, or whether you see it in the graph where it crosses, that's two ways, two representations. And then tomorrow, we're going to learn how to use the equations to find this solution as well. May the math be with you.